Hello, good morning. Today is December the 2nd, and I went over chapter 9 review in the last 2 days on Tuesday, November 30th, and yesterday, December the 1st. And you can see the recording, and here are the notes. Now, today, instead of Q&A that I usually do on Thursday, I will cover part of chapter 10 review and we'll make it supplement for lesson 26. Our lesson 25, let me show you. Our lesson 25 actually covers, I don't need that actually. Our lesson 25 actually covers the conic section on parabola and ellipse. And lesson 26, I don't have it here, but you can go on watching it from week 15. Yeah, in the announcement. Let me bring it there. If you go to announcement, you can see a complete view. Yes, and on lesson 25 is on parabola and ellipse. Lesson 26 is on hyperbola. Now, your test 4 will be up to lesson 24 only. And I provided you my old test with solutions here. Okay, now, so what I will do today will be the supplement of lesson 25 and lesson 26, actually. Okay. So the lesson 25 and 26 are the lecture part of conic sections, and then what I will do today is the supplement part of lesson 25 and 26. Okay, but I don't need you to watch this right away today. I rather you finish lesson 24 and watch a little bit lesson 25 with the supplement of for lesson 24, and then prepare for your test 4. Okay, now conic section chapter 10.1 to 10.3 will not be in your test 4, but it will be in your final. Okay, let me just start. Let me save this first, and then we go to our notes. Okay, again, proceed only after you are done studying from 10.1 to 10.3. Those are in lessons 25 and 26. Okay, now these topics 10.1 to 10.3 will not be in your test 4, but it will be in your final. Now, before we really start, let's review a little bit. 10.1 is on parabola. is on parabola. Give me a second. Now, parabola has the following pattern. Now, the one we usually use earlier this semester was something like this: y equals to x squared and all the variations, right? But we can now see this. We can now see this as x squared equals to 4py. Of course, in this situation here, the p is the coefficient of y is 1. Therefore, in the context of this 10.1, the p is actually 1/4. Okay, now, but I think the focus will be this. Why do we want to deal with this situation? Now, because that p actually gives us extra information. Okay, now we know parabola will look like, this parabola will look like an open up parabola. Yeah, it will be an open up parabola. I try not to draw it too big, but at the same time, I don't want to lose the detail. Okay, so the parabola, let's say, looks like this. Okay, with the vertex at origin. right? Okay. But then we have additional informations right now. This P actually tells us how far the focus away from the vertex. This is the focus here. This is the vertex. Now, the distance from vertex to focus is equal to P units into the curvature of the parabola. And furthermore, we have directrix. That's a line to which, that's a line, this is the directrix. That's a line to which every point on the parabola has equal distance from the focus as from the directrix. Okay. The distance from the vertex to directrix is also P units. Okay, now we will do examples about this later on. Okay. Now, likewise, what happened if we interchange, we swap the x and the y. Let's say we have y squared equals to 4px. Then the parabola will open to along the x-axis, and in this case, it will open to positive x-axis. Okay, let's say that's the parabola. Let's say this is the parabola. Okay, then this is the vertex. Okay, the focus will be in the interior of the parabola. The distance from the vertex to the focus is P, and the distance from the vertex to directrix also P, but in the opposite direction of to focus. The distance here is also P. Okay, such that for any point on the parabola, the distance from the focus to that point is equals to the distance from the directrix to that point. Now that's about parabola. Next, how about ellipse? How about ellipse 10.2? Now, ellipse has it's basically a deformed circle. It's a circle that you stretch horizontally and vertically at different scale. So suppose I have this ellipse like this. Now, the ellipse will have major axis, horizontal major axis, if the a squared, which is under x squared, is greater than b squared. Okay, then it will be, the major axis will be horizontal, and the focus, we call this major vertex. This is major vertex. This is minor vertex. This is minor vertex. Some textbook actually use capital V and lowercase v to represent major and minor vertices respectively. Okay, but I think we will use capital MV for major vertex and lowercase mv for minor vertex. And the focus, let me use screen. The focus will be on the major axis, and the distance from the center of that ellipse to the major axis denoted by C, which is equal to, we have this equation, C squared equals to the larger denominator minus the smaller denominator. Okay, now, if on the other hand, the b squared, that is the denominator of y squared part, is greater than a squared, if b squared is greater than a squared, then the ellipse will be basically stretched vertically more than stretched horizontally. Not good. Okay, so if we look back, this is A, this is negative A, this is B, this is negative B. Likewise here, this is A, this is negative A, this is B, this is negative B, right? But because B squared is greater than A, then the focus will be on the major axis, which is on the y-axis. Okay, the foci are here. The foci are here. And the distance from the center of the ellipse to the foci is equals to C, where the C squared is the greater denominator minus the smaller denominator. Okay, now last one is on hyperbola. That's in 10.3. Now, if our hyperbola start with x squared minus y squared term, then the hyperbola will open to left-right. In other words, the axis of this hyperbola is parallel to x-axis. So let's say hyperbola will be something like this. Okay, the hyperbola will be something like this. Now, the vertices here are, again, this is A and this is negative A. Okay, now the focus is again in the interior of that ellipse. Okay, and the distance from the center of that hyperbola to focus is C, where C squared is A squared plus B squared. Okay, and we also have remember that we have asymptotes. Now that asymptotes actually connecting the corners, the diagonal corners of this rectangle here. We call that auxiliary rectangle, remember? Right? Okay. Let me draw that rectangle. What color should I use? Let me use green. So that auxiliary rectangle, rectangles, if we connect the corners, the vertices, diagonal vertices of the corners, then we will get these asymptotes here. Of course, my graph is actually not good though. I'm trying. Okay, let me erase this first. This one also, and then I try to fit in the hyperbola. Now remember that the hyperbola actually gets closer and closer, but not crossing, closer and closer, but not crossing the asymptotes. Okay, now that one is not good. I think this one is better. Okay, now, and if we look back into that rectangle, this is actually B and negative B. Now, suppose, on the other hand, if I make the graph like this, what color should I use? You know what? Let me copy paste that thing. Yeah, let me copy paste this. Yeah, but what I want to say is, like, suppose I change that y squared over b squared term comes first, minus x squared minus a squared equals to 1. Then the hyperbola has the same frame. Okay, it has the same frame, but the hyperbola actually on a vertical axis. Okay, so the hyperbola will be approximately something looks like this instead. Okay, now the focus is no longer here. It's no longer here. Throw it in. This is not what I want. Yeah, the focus is no longer on x-axis, but it will be on the y-axis. Okay, the distance from the center are the same though to what we have earlier. So these are C units. Okay, now I hope that's good enough, a brief review of what we learned there. Let's start with the review then. Now, what I will do is the following. We see an equation, like in number 2 here. We get an equation. We will try to answer those questions first. Okay, but if we can put more details, even though they don't ask that, we will do so. Okay, now let's see, for example, number 2. We have y equals to 8x squared plus 32x plus 33. Now we have x squared, but the y has no square. Okay, so we have x squared term. Okay, and we have y term, but no y squared term. Yeah, conic section should have x squared or y squared or both. Now, if you only have x squared without y squared, then it must be parabola. Okay, so what I will do next is to rewrite this, okay, so that it match with the pattern of what we have before. Okay, so I move the 33 to the left-hand side, and I will factor 8 from the first 2 terms on the right-hand side. And then I will complete the triangle, complete the square here. When I complete the square, I will add, I guess I will add 4, to complete that, right? But if I add 4, then on the right-hand side, I actually add 4 times 8, right? Okay, so I will compensate that by subtracting by 4 times 8, which is 32. Now think about this. Think about this. You see that I have new term here, right? 8 plus 4 times 4. It means on the right hand side, I have extra 32. Now I need to compensate that by 32. Okay. Now then, I think what I will do is I will add both sides by 32. So I get y minus 1 equals to 8 times x plus 2 squared. Okay, and this is 1/8 times y minus 1 equals to x plus 2 squared. Now from here, then we can start reading. For example, the parabola is actually opens up, right? The parabola opens up. The center is at -2, 1. The parabola opens up. -2, 1. Okay, and we would like to know where the focus and directrix are. Now 1/8 is 4 times 1/32, is it right? Remember the 4py thingy? We need to find the p. We need to find the p. Okay, so from here we see that the p is equals to 1/32. Okay, so if I just do that, if this is the vertex, which is -2, 1, and it opens up, then the focus will be 1/32 units up. Okay, and the directrix will be 1/32 units down. So this is y equals to 1 minus 1/32. Okay, the directrix is 31/32. Okay, let's put the framework there. Too big, huh? Unnecessarily big. Let's make it this way. So this is the y-axis, and this is the x-axis, approximately like this. Okay, and the parabola will be something looks like this. Okay, now of course we can find, for example, we can find the y-intercept, right? We can find the y-intercept. The y-intercept is what? Oh, the y-intercept is 33. So it's actually a lot sharper than this. I didn't draw it to scale. I didn't draw it to scale. So it should be like this, I think. Right? Okay, but because I don't draw it to scale, then it's hard for me to make it super precise. But the y coordinate, the y-intercept here, it should be 0,33. Okay, let's see what it really looks like. So y equals to, let me share with you my full view. Y equals to 8x squared, because the 8x squared, you know that the parabola becomes very, very skinny. Yeah, that's what it looks like. Okay. That's what it looks like. Zoom it out. So it becomes like this. Okay, if we zoom it in, see, that's what happened if you use the graphing calculator to cheat, then you will not see all the details at once. Okay, because the Y-intercept is very high up there. Okay, but the focus is actually very low down here, right? You see, so I can only do, if I want to do screenshot, then I will do screenshot here. Let me screenshot that and then put it on our notes. So this is the actual view. Still covered. That's the actual view. I think it gets cut. You know what? I don't like that. I think this is better, right? Okay, but then if we put more details, you see that the vertex is -2, right? And then the focus is actually 1/32 higher than that. So it's like very close here. Oops. And then the directrix is very, very close to 1. It's like only 1 minus 1/32. So it's like this. This is the directrix. Okay, not a good idea. Give me a second. And then again, going back to the focus here, the coordinate of that focus is -2, 33, 32. Okay, now this is especially important if you are actually graphing this without graphing paper. If you don't give me graphing paper, Thomas, then what you want me to show? Well, I need you to show the coordinates. Okay, let's say you draw it this way. Okay, I know it's so hard to graph it to scale, but try to give me the details in coordinates. So you say this is the vertex here is -2, 1. This one is 0,33. And this one here is the focus. This is the vertex, right? The focus is -2,32. And then the directrix. The directrix is y equals to 31/32. Okay, because you don't draw it to scale and then you don't have graphing paper. Even if you have graphing paper, it's so hard to put all the details, right? Okay, so write down the coordinates. Okay, now that's for this number 2. Let's go on to number 4. Number 4, we have 9y squared equals to 144 plus 16x squared. We have x squared, we have y squared. So it's either ellipse or hyperbola, right? Now, but we need to make it into something equals to 1. Okay, and then the x squared, y squared term on the same side. And we see the operation in the middle. Is it positive, which will make it ellipse, or subtraction, which will make it hyperbola? Okay, so let's see. I will move the 16x squared to the left-hand side. And that 144 should becomes 1, right? So I will divide by 144 here. If I divide by 144, I get y squared over 16 minus x squared over 9. Then from here we see, oh, that's a hyperbola. And the axis is parallel to y-axis. Right? Actually, because the center of this hyperbola is origin, then the axis will be equals to the y-axis. Okay. Now, let's say this is the center, which is 0, 0. Then we will go 4 units up because this is 16 is 4 squared, right? We will go 4 units up and 4 units down. That's for the vertices. Okay, now the auxiliary box, the auxiliary rectangle will have 4 units up down from the center and 3 units left right from the center. So the auxiliary box is approximately like this, let's say. Now that way, then we have the asymptotes here. Okay, this is the rectangle, the coordinate system. Oh, what is the equation of that asymptotes? The asymptotes has the equation y over 4 equals to plus minus x over 3. You see, you can think of it this way. You do the square root here equals to the square root of this. Okay, of course, you square root both sides. Don't use this one here. And then you set them equal to each other. Don't forget the plus minus. And as usual, we will rewrite it in slope-intercept form. So y equals to plus minus 4 over 3x. Okay, so this one here will be y equals to 4 over 3x. This one here will be y equals to negative 4 over 3x. Okay, the parabola, the hyperbola will open this way, parallel to y-axis, right? Remember? And where's the focus now then? The focus will be, of course, somewhere here. But what are the coordinates of the focus? The focus, c squared equals to a squared plus b squared. So c squared equals to 16 plus 9, which is 25. So c is 5. That's 5 units up and down from the center. Okay, you may want to put some details that this is actually 3, 0 and negative 3, 0. Okay, now that's for number 4. Let's go on with number 6. Oh, number 6 is already equals to 1. We have x squared term and y squared term, and the operation between is addition. So this must be an ellipse, right? Now, the problem, however, is this is not in standard form. So let me rewrite it first. This is x squared over 1 over 25 plus y squared over 1 over 36. Okay, because 1 over 25 is greater than 1 over 36, then the major axis is parallel to x-axis. Is it right? Okay. In fact, the center is 0, 0. Okay. The center is 0, 0. Let me write it here. Let's say this is the center. And I go to the left, right, as far as A units, okay, which is 1/5. The center is 0, 0. So the major vertices are 1/5, 0 and negative 1/5, 0. Okay. The minor vertices is 0, 16, 0, negative 16. Fix this one. Approximately here. Okay. And then, yeah, the rectangle, the coordinate system. Move this a little bit. Okay, and the focus will be inside, right? The focus will be inside. Now, where's the focus? The c squared equals to the bigger squared minus the smaller squared. That's 36 minus 25 over 25 times 36. 11 over 25, 36. So c is equal to square root of 11 over 5 times 6, which is 30. So I'm sorry, this is 11. But 11 is slightly more than 3, right? So this is slightly more than 3 over 30, which is 1/10. Okay, so the vertex is actually very close to the center, though. The vertex is actually very close to center. You know what? How do I put that? So the coordinate here, the vertices, this guy will be square root of 11 over 30, 0. And this guy here, that's the focus. This one here will be negative square root of 11 over 30, 0. Okay. We don't need this information actually. And just write the coordinates in exact form. Okay, don't make it decimal. Okay, don't make it decimal. Just leave it like that. You need to simplify, but when we say simplify, it's not in converting it to decimal. Okay. Number 8. Number 8, we have x squared term and y squared term on the same side already, and the operation in between is addition. So it must be an ellipse again. Now, then we need to kind of play around with this, modify the equation first so that it matched with the picture, the pattern that we have. So I factor the 3 out here. It means I need to add 9. I factor a 4 out here. I need to add 1. So you see on the left-hand side, I add 3 times 9, which is 27, and 4 times 1, which is 4. So negative 19 plus 27 plus 4. 3x minus 3 squared plus 4y plus 1 squared equals to, what's that? Is it 12? 31? Yeah, it's 12. And then if we divide by 12, then we will get x minus 3 squared over 4 plus y plus 1 squared over 3 equals to 12. So that's an ellipse. Center is 3, -1. Now, because 4 on the denominator is on the x part greater than 3, which is the denominator of the y part, then this ellipse will, the major axis is parallel to x-axis. Okay. So let's say the center is 3, -1. Okay, we will move 2 units to the left, right, to get the major vertex. That's 5, -1 and 1, -1. We will move up and down radical 3 units to get the minor vertices. That's 3, -1 plus radical 3. Again, don't make it decimal. 3, -1 minus radical 3. So the ellipse is approximately something look like this. That's not what I want. Yeah, approximately like this, right? Yeah, let's put the rectangular coordinate system. Now then, what happened with the focus? The focus, c squared equals to 4 minus 3, which is 1. So c is 1. It is 1 unit to the left and right of the center. So if I move 1 unit to the right, that will be 4, -1. That's the focus. And 1 unit to the left, that will be that's 2, -1. Okay. Now we are done with this ellipse. Let's go on. Number 10. We have y squared term and no x squared term. We have x term though. So this will be a parabola, right? You know what? Let's move the 3 to the other side first. X minus 3 equals to 2. I will factor the 2. And then complete the squared. And then compensate. Right? So I will get x plus 5 equals to y times y plus 2 squared. This is y plus 2 squared equals to 1/2 x plus 5. So this parabola will opens to positive y-axis. No, I'm sorry, a positive x-axis. Yeah, the parabola will opens to the right-hand side. Okay, the vertex is -5, -2. Okay, let's put it this way first. That's the vertex. Okay, now how about the p? I need to rewrite these. So a lot of rewriting, and you need to show me that rewriting though. You need to show me that rewriting. right? So once you have that, blast squared equals to 4 times something, 4 times p times x plus 5, then this p, from there you can read p is 1/8. Okay, p is 1/8, which means if this is the vertex, -5, -2, then we will move 1/8 unit to the right to get the focus. Okay, the focus is -5. If I plus 1/8, -16, I'm sorry, yeah, -16 plus 1, -15 over 8. That's the focus. This is the vertex. Okay, and the directrix will be the same distance from the vertex as to the focus, but opposite distance. Okay, the directrix is x equals to -2 minus 1/8. That is -17 over 8. Now, the parabola will look like this. Okay, the parabola will look like that. Number 12. Number 12, we have x squared and y squared, the same side, right? So it's either parabola, I'm sorry, it's either ellipse or hyperbola, but they have opposite sign, right? I mean, positive x squared and negative y squared. So this must be a hyperbola. I will factor 4 and about to complete the square after that. I will add 25 here to complete that, which means I add 4 times 25, that's 100. And I will add 16 here, which means I subtract by 16. So I will get 4 times x minus 5 squared minus y plus 4 squared equals to -4. Oh, okay. So if I divide by -4 to make it 1, on the right hand side, this becomes 1, then this will be x minus 5 squared over -1 minus, actually becomes plus y plus 4 squared over 4. Nah, I don't like this. This is y plus 4 squared over 4 minus x minus 5 squared over 1 equals 1. So you see a lot of rewriting. But Thomas, can I just write x minus 5 squared without over 1? Actually, you okay, but I don't think you want to do it that way because you want to make it feasible, right? You want to make it feasible. Now, from here, we see that the center is 5, -4. Okay, the center is 5, -4, and the axis is parallel to y-axis. We move up 2 units to get the vertex, right? So that 5, -2, and down 2 units to get the other vertex. The auxiliary rectangle is 1 units left right from that center. Yeah. Okay. more space. So let me do this. Center should be somewhere around here. Okay, and then these are the asymptotes. The asymptotes are, you keep the same color, asymptotes are y plus 4 over 2 equals to plus minus x minus 5 over 1. Or we can say y plus 4 equals to plus minus 2 times x minus 5. Okay, so this will be y plus 4 equals to 2 times x minus 5, which is 2x minus 16. And this one here is y plus 4 equals to negative 2 times x minus 5, which is y equals to negative 2x plus 6. Okay, and the hyperbola, therefore, will be something that looks like this. Okay. Oh, we still need to find the focus then. The focus is, yeah, do it here. To find the focus, c squared equals to 4 plus 1, which is 5. So c is radical 5. Slightly more than 2, right? So the focus will be here, 5 comma negative 4 plus radical 5. And here, 5 comma negative 4 minus radical 5. Okay, so now we have all the details for this hyperbola. Let's move on. Number 14. So I hope at this point you realize that we have we need to do a lot of completing the square, okay, and reading the patterns. And I hope that actually helps moving forward. Give me a second. Number 14, I hope you get more and more get used to this. You see that x squared and y squared term on the same side, and they have this positive, both positive signs. Then this must be an ellipse. What we'll do next is to regroup it so that we can easily complete the square. This is 4 times x squared minus 6x. I think I will need to add 9 here. And I will need to add 4 here. So we get 4 times x minus 3 squared plus y plus 2 squared equals to 4 divided by 4. That gives us x minus 3 squared over 1 plus y plus 2 squared over 4 equals to 1. So it's easy to see that the center is 3 comma negative 2. Okay, and because the denominator of y plus 2 squared is greater than the denominator of the x squared term, then the major axis will be parallel to the y-axis, right? So from there we see that, oh, from the center we go up 2 units to get the major vertex, 2 units down to get the other major vertex, move 1 unit to the left, right, to get the minor vertex. Okay. Just to help. This is just to help. This is not the rectangular coordinate system, just to help. And then for the focus, c squared equals to 4 minus 1 equals to 3. So c squared, c therefore equals to square root of 3. So the focus will be 3 comma negative 2 plus radical 3. That's the one of the focus, one of the foci, and this is another one. 3 comma negative 2 minus radical 3. Now we go on to the next level. So what we had before, 7 questions. We did 7 questions where we were given equations. And now, and then we try to get the vertices, the foci, and all possible informations, right? In number 17 and 18 and on, we go backward. Suppose we are given informations, can we come up with the equation instead? Okay, let's do number 18. Number 18. It's almost impossible to do this kind of problem without sketching the graph. So at least sketch that, okay? So that you know what you actually know. So the x-intercepts are negative 11, 0, and 3, 0. And it passes through 2, 39. So 2, 39. So we can imagine that the parabola will be something like this, right? That's what the parabola looks like. Okay, and we can see here that the axis with vertical axis. So the vertical axis is here, right? Okay, we need to find the center though, the vertex, right? How to find the vertex? Let's first find the axis of symmetry. The axis of symmetry, this is x equals to negative 11 plus 3 over 2. That's negative 8 over 2. That's negative 4. Okay, so the vertex must have, negative 4 comma something. Let's call that k. So at this point, we know our equation must be y minus k squared. Actually, y minus k equals to 4p x plus 4 squared. So I should put the 4p actually here. Okay. It must look like that. We need to find the k. We also need to find the p, right? Okay, let's do that. What do we know from these informations? We know that first that 11, 0, 3, 0 are x-intercepts, right? So it passes through 3, 0. Let's plug that in. Y minus 0 equals to 3 plus 4 squared. So we get 4py equals to 7 squared, which is 49. Okay. Now, another one is we know that it passes through 2, 39. So we have 4py minus 39 equals to x plus 4. This is 4py minus 4p times 39 equals to 6 squared is 36. But 4py is 49, right? 4py is 49 minus 36 equals to 4p times 39. What is that? That's 13. So 4p is 1/3. Now we don't need to find the p, right? We just need the equation. So the equation is therefore given by the 4p is 1/3 compared to this. Okay, so 4p is 1/3 y minus k x plus 4. I still need to find the k though. I still need to find the k. How should we do that? Oh, you know what? I actually make mistake here. I actually make mistake there. In fact, that's a very bad mistake. The y is 0, not the k equals to 0. I need to fix it. So 0 minus k. So this is negative 4pk equals to 49. Yeah, this one is also incorrect then. My bad. So the y is 2 minus k, right? So this is 8p minus 4pk. Is that right? Yeah, but minus 4pk is 49. So this is 8p plus 49 equals to 36. You know what? Let me resolve this. Equals to 36. What am I doing? No. The x is 2, the y is 39. The y is 39. The y is 39. So it should look like this, 4p39 minus 4pk. So 4 times 39 times p, my bad, plus 49. So 4 times 39p equals to negative 13. So p equals to negative 13 over 4 times 39. That's negative, I cancel this, I get 1/3, right? So this is negative 1 over 12. Actually, I need 4p though. So 4p will be divided by 39. That's good enough. 1/3 there. Negative 1/3. Negative 1/3. But I still need to find the k, huh? I still need to find the k. How to find the k? Oh, we know that 4p is negative 1/3. So negative 4pk equals to 49. Okay. It's negative 1/3 times k equals to 49. So k equals to 49 times 3. That's 147. Okay, I use this one here. So the equation then becomes 4p times y minus k equals to x plus 4 squared. Okay, that's for number 18. Number 20, find an equation for the conic that satisfies the given condition. We have this parabola for number 20. Parabola. Okay, the focus is negative 4, 0. And the directrix is x equals to 4. Now you know that the center or the vertex has to be in between, right? Okay, it must be in between the directrix and the focus. Okay, of course, then from here we see that the parabola should open this way, right? Now, the y component of that vertex must be the same to the y component of that focus. So this must be something, 0. Agree? But what is that though? What is the x component? The x component of vertex, it must be the midpoint of negative 4 and 4. That's how we get that. The vertex is actually origin. Huh. Now we also see that the p, which is the distance from the vertex to the focus, is 4. In fact, it's actually going to the negative side. That's negative 4. Okay, so the equation of the parabola must be x equals to 4p times x equals to y squared. That's if the center, the vertex, is origin. That's if the vertex is origin. Okay, but because the p is negative 4, we end up with 4 times negative 4x equals to y squared. It's negative 16x equals to y squared. Okay, that's for number 20. Let's go on. Number 22, a parabola again. Parabola with vertex as origin, symmetric with the x-axis. So either it opens up this way or this way, we don't know. Okay, containing the point 5, negative 1, 5, negative 1. So it must be the one on the right-hand side, huh? But for the one on the right-hand side, it must be 4py equals to x squared. No, actually 4px equals to y squared. Okay, the center or the vertex is origin, right? So it must be x and y squared without the plus minus thingy. But we need to find the p though. we need to find the P. How to do that? Well, just plug in the coordinates. The center is origin. That gives us that. Opens right. And then we plug in 5, -1. So 20p equals to 1. So 4p is 1/5. Right? So that is 1/5 x equals to y squared. Okay, that's for number 22. Oh, can we use that to find the focus? And of course, if you want, you can go on further, find the directrix. Okay, where's the focus though? The focus will be on the right-hand side of the vertex, right? Okay, and the distance is the P is 1/20. Okay, so the focus here will be 1/20, 0, and the directrix, that's x equals to -1/20. Okay, remember this, the vertex is origin, right? That's for number 22. Let's do 2 more questions and then I end this lecture. This lecture today. Now we have a hyperbola, number 24. The foci are ±10, 0. So the 10, 0 and -10, 0. Oh, by the way, then the center of that hyperbola must be origin then. The center is the midpoint of foci, right? So the center is -10 plus 10/2, 0 plus 0/2, that's 0, 0. Okay, and because the foci is parallel to the x-axis, in fact, it is on the x-axis, we are sure because foci and center are collinear. And parallel to x-axis. Okay, in fact, the center is 0, 0. Then the equation must be x squared minus y squared equals to 1. Agree? Now, more things to say. The vertices are ±5. So the vertices are 5, 0 and -5, 0. Actually, you can use the vertices also to find the center. Okay, so we know that the parabola will be like this, right? Okay, now because the distance from center to the vertices are 5 units, then the A equals to 5. It's distance from center to vertices. So we get x squared over 25 minus y squared over b squared equals to 1. Now the c is 10. That's the distance from center to foci. But we know c squared equals to a squared plus b squared. We will use this to find the b squared. So b squared is 75. Now from here, then we know that equation is x squared over 25 minus y squared over 75 equals to 1. Right? Now, then something they didn't ask us, can we then, using that equation, to find the asymptotes? Actually, not too hard to do, right? We already have the equation. So the asymptotes are, we are done with the question actually here, once we get the equation, right? But the asymptotes are x over 5 equals to plus minus y over square root of 75. Okay, so y equals to plus minus square root of 3x. I multiply both sides by 5 radical 3. Okay, last one. Now we have ellipse. The foci are 2, 0 and negative 2, 0. Therefore, the center, oops, let me use blue color. Center is the midpoint of foci. That is negative 2 plus 2 over 0, 0 plus 0 over 2. I'm sorry. That's origin. Okay, so the center is origin. And once we know it's ellipse, then it must be x squared over a squared plus y squared over b squared equals to 1. Right? Okay, it must be that. Now, this is the difficult part though. It passes through 2, negative 2, 2, negative 2. I'm sorry, 2, radical 2. So the ellipse is approximately like this. I wonder if you can imagine that. Right. So this is the major axis. In fact, I can just go this way. Right. Okay. So we need to find the major axis, the minor axis. However, we know that the distance from the center to the foci is 2. Okay, so we know that c squared equals to a squared minus b squared equals to 2 squared. In other words, a squared plus, I mean minus b squared equals to 4. Thomas, how do we know it's not b squared minus a squared? Well, because we know that the major axis is parallel to x-axis. So the a squared must be greater. Okay, the denominator of x must be greater than the denominator of y term. At the same time, this equation must satisfy, also this is the first equation. The second equation, it passes through 2, radical 2, right? So 2 squared over a squared plus radical 2 squared over b squared equals to 1. Right? So 4 over a squared plus 2 over b squared equals to 1. Is it okay? Now from here, you can do substitution actually. Let's do this. A squared equals to B squared plus 4. Is that right? Then we solve this equation. Okay, we solve this equation. I don't really like this though. Multiply by the LCD. B squared plus 4. That gives me b squared plus 4 equals to 4b squared plus 2 times b squared plus 4. That's 4b squared plus 2b squared plus 8 equals to b squared being squared plus 4b squared. Yeah, I keep that as in a b squared so that we can have quadratic-like equations. 4b squared cancels, so I have 0 equals to b squared being squared minus 2b squared minus 8. So we get b squared equals to 4, b squared equals to -2, but no, that means the b is imaginary number, right? And notice that we just need to find the b squared. We don't need to find the b, right? The b squared is 4. Maybe I copied it down. So x squared over a squared plus y squared over b squared equals to 1. Now we know that b squared equals to 4. And a squared equals to b squared plus 4. That's it. That's the equation. Okay. Now you see that what we did here is I know it's quite complicated, but you need to, one of the ability that you need to keep developing in pre-calculus, and I say this many times since the very beginning, is your ability to graph, okay? Not only graphing, but knows the details of the graph such that you can go backward to find the equation, right? But even when you try to find the equations, you need to know the pattern. You need to have pretty good algebra, okay? And so basically, you see that you have geometry, basically the graphing, okay? And connect that with your algebra. Okay, this is the emphasis of pre-calculus. This is one key element in pre-calculus. Okay, so ask yourself in the last question, if you get stuck, where do you get stuck? Trust me, you get stuck usually because you cannot connect the dots. It's like you know this information, you know another information, you know it's an ellipse, you know it's the foci, you know it across the point, so what? Okay, you need to find the center first. Okay, Thomas, I can find the center. So what? Okay, what do you know if you have the center? Means you can already write this, right? If you know the center and that it is an ellipse. Does it make sense? Okay, now then, knowing that the foci is 2 units from the center, then you have this equation. On the other hand, because you know that this ellipse going through this point, then you have this equation, right? Now put these things together. Put these things together with this. and then you solve it. Now, of course, when you see this rational equation, you may get scared a little bit, but then you ask yourself again, in chapter 1, chapter 2, did you learn to solve rational equations? And did you learn quadratic light equations? So all of a sudden, so many things put together, okay, in one question. That's why this question, is it hard? It's actually not hard. It's tedious. Okay, you can say it's a bit longer than usual. It's not hard, but a bit harder than usual. It's more because you put too many things together. Okay, but that's what happened in our real life, though. Can you connect the dots? I mean, not only in math, in real life, can you connect the dots? Do you have situation in our life that can be solved in one single step? No, most of the time that's not the case. The older you are, the more mature you are, the more you see, hopefully, that most of our life issue are actually requires multiple step solution. Okay, it's not that oh, you know what, I want to have a good life, then what I need to do is just go to college. No, it's actually more than just go to college. You go to college, you take appropriate classes that is in line to your passion, what you want to do. Okay, so you don't want to work in the field that you don't have passions, that every time you go to work is actually a torture for you. No, but at the same time, you don't want to work in a field that's not generating enough financial income to support you and hopefully your family, right? Okay. And I want to say that the field that generates more money right now is the STEM program, STEM field. There's science, technology, engineering, math, right? Okay. It's not easy though to go to this kind of field. You need to build yourself around the math, from math, and then from there you learn physics, or if you want to be an MD, more chemistry and biology, of course. It's not just that one single step, just go to school and then you slack off. No, it's a lot of things put together. Okay. So if you find that your life seems to be quite difficult to solve, welcome to life. You're not alone. Okay. And it's supposed to be a good news that you're not alone. Figure that out with other people. Okay. Feel free to share with me. And we have counselors at school, at SMC, at West LA College, at East LA College, that you can talk to. Like, you know what? I have this situation. This is my aim. This is my goal. What should I do to come from where I am right now? And this is what I want to be. How to get there. Okay, now in between, you need to take more classes to support you to be able to get to go to good schools, and then from that good schools you take your MD, let's say, but in between you need to take a lot of classes, practice the MCAT, learn to study and focus in multiple hours, right? Okay, and you may need to volunteers to to hospitals, get some connection with doctors so that you know more about the field you're getting into, and so on and so forth, right? And unfortunately, life is not just about getting a job, right? It's I hope you also have in mind to get a family, right? To share your happiness, your life burden together with somebody else. Okay, and contribute more to your society, of course, after that, right? Okay, it's multiple steps, and all of them requires dedication, commitment, and responsibility. Okay, learning process in between. Okay, I think that's for today, and that's for this semester. I hope you do well in your tests, not only your test 4, but also your final. And when you go to calculus, you can survive that class and even excel in that class. Okay, I hope you enjoy this semester, and forgive me if there are things that I didn't say correctly, happen to be offensive to you, but my purpose is so that you can learn as much as you can from me and survive the next class. Okay. In fact, I want to say this, that it doesn't matter you like me or not as a person. It doesn't matter you like me or not as an instructor. My pleasure will be when I hear you are successful in your next class. Okay. The best way to know if I'm a good teacher or not is not what grade you get from me. It's not how much you like me, but it's how well you do in the next class. Okay. At least in the first semester, the first half of that semester. Okay, I need to provide you the foundation, not only the mathematical one, but also how to survive, okay, how to study, so on and so forth. Okay, and I wish you the best, not only for your test and final, but also in your next class. See you then.